Let's delve into the world of conditional probability. You should already know that probability refers to the relative possibility that an event will occur, as expressed by the ratio of the number of favourable outcomes observed to the total number of possible outcomes. For example, the probability of a flipped coin landing on a head would be 1/2. Conditional probability refers to the probability of an event given that another event has already occurred. Before we get started exploring this concept, here are some symbols you need to know. The probability of B given A, the probability of A and B, and the probability of A or B. The formula for conditional probability is expressed for events A and B as the probability of B given A is equal to the probability of A and B divided by the probability of A, where the probability of A does not equal 0. A is known as the reduced event space. Let's make sense of this by going through some examples. Suppose 35 seasoned travellers are interviewed about their overseas trips. Of these, 30 have visited Europe and 17 have visited South America. Suppose we want to calculate the probability that a person has visited South America, given that they have also visited Europe. To be able to apply the formula for conditional probability, we first need to calculate the intersection of E and A. In other words, we need to find out how many travellers have visited both Europe and South America. To do this, we use set theory. The total number of travellers is equal to the number of travellers who have visited Europe, plus the number of travellers who have visited South America, minus the number of travellers who have visited both. If we put in our known values, we can rearrange the equation to find the intersection of A and E. So 30 plus 17 minus 35 gives us 12. Therefore, 12 people have visited Europe and South America. Now that we have this information, we can find the probability that a person has visited South America, given that they have also visited Europe. To find the probability of our previous finding, we simply need to divide by the number of travellers interviewed, 35. Similarly, to find the probability of E, we divide the number of people who have visited Europe by 35. According to our formula, for conditional probability, we need to divide these probabilities. Here we go. So if we put this into a calculator, we find that the answer is 2/5. Hence, the probability that a person has visited South America, given that they have visited Europe, is 2/5. Hopefully now you have a better understanding of how conditional probability operates. We mentioned before that conditional probability reduces the event space. By reducing the event space, the probability of the desired outcome increases. Suppose someone is rolling a regular die and you are asked to guess what number the die lands on. The event space for the roll is 6, since there are 6 possible outcomes. The probability of you guessing correctly is 1 in 6. Let's define event A as rolling an even number, and event B as rolling a 2. If we are given the information that an even number is rolled, the event space is reduced to 3 possible numbers, and the probability of the die having landed on a 2 is increased. If we use our conditional probability rule, we can find the probability of a 2 given that the die has landed on an even number. Probability of B given A equals the probability of A and B divided by the probability of A. So the probability of A and B is equal to 1/6. Divide that by the probability of A, which is 1/2, and you get the probability of B given A, which is 1/3. It can be concluded that the probability that the die rolled lands on a 2, given the information that it lands on an even number, is 1/3. Now that we've covered the basics, Let's try out some more complex examples.
Created using Powtoon.